All right, we are now continuing with Indicator 2, and we've already worked on the first part of this lesson, which was rational numbers. And we had talked about repeating and terminating decimals. And now we are getting into adding and subtracting rational numbers. And our learning target for this one is I can apply addition and subtraction with rational numbers to model real life problems. Okay, so the vocabulary that we must know in this is additive inverse, and we have talked about that a number which is a certain distance from zero on the number line, its additive inverse is actually going to be the opposite. Okay, so let's say I give you some of these numbers and we talk about the additive inverses. Um, so two rational numbers are opposites, just like I've shown you over here, 3/4 and -3/4. So two rational numbers are opposites if they are represented on a number line by points that are the same distance but on opposite sides from zero. Okay, so um, from here I have 3/4, and the opposite side of that is -3/4. So -3/4 is the additive inverse of 3/4, because when I take the sum of a number and its opposite or the additive inverse, I am going to get 0. So if I do -3/4 plus 3/4, I am going to get 0. Okay, so that is the rule. Sum of a number and its additive inverse is going to be 0. Okay, so let's look at this. The additive inverse of -7/8 would be 7/8, because when I add these two, I am going to get 0. Okay, -1/8 is going to be 1/8. So this is the additive inverse of -1/8. Additive inverse of 6500 is going to be -6500. All right, so that's what additive inverse means. Now let's go ahead and start solving some problems with rational numbers. And let's say I give you a question, and it's talking about Annalise earned $36.82 at her part-time job. Okay, so let's say Annalise has earned $36.82, and this is at her part-time job. And then babysitting, she earned $18.50. Okay, $18.50. So we are looking at what is the total amount she earned. So in order for me to calculate the total amount, I am going to add both of these. All right, and when I add $36.82 and $18.50, I am going to get $55.32. All right, so when you ask what is the additive inverse of this, it would be -55 and 3200. Okay, so basically whenever you're solving problems, you're finding the total. That is addition over here, where total obviously means sum. All right, and then the additive inverse would be the opposite of what I have, which would be -55 and 3200. Okay, so now let's go on into problems in which I need to know about rational numbers is the rules that apply to adding fractions and decimals. They also apply to rational numbers. And the rules for adding integers also apply to positive and negative rational numbers. Okay, so if I have terminating decimals, if the fractions and are decimals, if the fractions are decimals that terminate, you can use decimals or fractions to add. Okay, And if it's a non-terminating decimal, if the fractions are decimals that represent non-zero digits, use fractions to add. Okay, so we are going to do some examples. And let's start with a problem. Okay, so let's say I give you -3 and 5/9, -3 and 5/9, okay, plus 1 and 2/9, plus 1 and 2/9, okay? So as we were saying earlier, the same rules of adding, subtracting integers applies to rational numbers also, all right? So we're going to use the same rule. I can see over here that I have opposite signs. So I am going to, just like we did with the integers, I am going to subtract the two numbers because they are opposite signs. And I'm going to give it the sign of the bigger number. Okay, sign of the bigger number. So first I am going to rewrite the problem. I can rewrite it as an improper fraction. Or I can just subtract otherwise also, but let's just do the first method that I was talking about. There are two ways to do this, okay? So I know that 9 times 3 is going to give me 27, plus 5 is going to give me 32, all right? So this is negative 32 over 9. And then I have 9 times 1 is 9 plus 2. So that gives me 11/9. Okay. And now opposite signs. So this is minus, this is plus. So 32 minus 11. And that's going to give me negative 21 over 9. All right. And then if I simplify this, I know that 9 and 21 are both divisible by 3. So this is going to give me negative 7 over 3. All right. And so when I convert this back into a mixed number, it is going to be negative 2 and 1/3. And that is going to be my answer. Okay, so you're going to rewrite the mixed numbers as improper fractions. You're going to add the numerators, and then you are going to assign any negative sign to the numerator. You're going to add it, and you're going to simplify and rename as a mixed number. Okay, so let's also try the other method that we've done in the past. So I'm just going to put negative 3 and 5/9, okay, and then I have plus 1 and 2/9, okay. So since they're opposite signs, I am going to subtract. I'm going to subtract, and I can take away 2 from 5, so, and then I can take away 1 from 3. So 3 minus 1 gives me 2. 5 minus 2 gives me 3 and 9th, right? And the sign in front of the bigger number is negative. And then 3/9 can be simplified. And so I actually get negative 2 and 1/3. So I just wanted to show you both methods. You can do it this way, or you can do it this way, converting it to an improper fraction. You will still end up with the same result. Okay, so we did not have to regroup at all over here because this was smaller, but if it wasn't, then we would be regrouping like we have done in the past. Okay, so let's try another problem, and let's go to this one, which would be -3 and 1/6 plus -2 and 5/6. All right. Now, you can do the improper fraction method, but it's always easy the other way also. So let me just show this to you. And I have -3 and 1/6, and I have -2 and 5/6. Okay. So both the same sign. So I am going to end up with a negative. 3 plus 2 is 5. Okay. And 1 plus 5 is 6. So 6/6 is nothing but, this is what? 1 whole, right? So that 5 and this 1, this equals your -6. Okay, because this is 1, you're going to add on to this one. So this becomes -6. All right. So this is how we are adding your rational numbers. Okay. Let's go ahead and solve a problem where I have two rational numbers in two different forms. Okay, one can be as a fraction, and then one can be a decimal. So now, if I have -2/5 and I have 2 and 3/10, we can do two things with this. I can convert both to decimal form, or I can convert both to fraction form. So both methods are going to give me exactly the same result. Okay. So let's start. We are going to add them both as decimals first. All right. So we are going to add them both as decimals first. And if I look at 2/5, all right, I know that this is, I can always convert it like this. So if I have 2/5, I can do, trying to make this over 10, because then it's easier for me to, because, decimals go in the 10th place value. So this would be times 2 and times 2, 4/10, which is what? This, right? So that is going to give me 4/10, and then this has the minus sign, so this would be minus. Okay, so I'm going to convert this to 4/10. So -4/10 plus 2 and 3/10. All right. Now, since they are opposite signs, I will have to subtract and then give the sign of the bigger number. So it's going to go this way. 2 and 3/10 minus 4/10. That's what we'll have to do. Cannot take away 4 from here. So this is 1. This is 13. And 13 minus 4 gives me 9 decimal 1. And the sign is going to be positive here. So the bigger number has the positive sign. So therefore, my answer is going to be 1 and 9/10. So I'm going to rewrite -2/5 as a decimal, which I did here. Okay, and then I'm just going to add them and simplify. So this is when I am converting them both to the decimal form. Okay, I can also convert them both to the fraction form. I can convert them both to the fraction form. Okay, so that I have the same format when I am adding or I am subtracting. Okay, so I'm going to rewrite the decimal as a fraction now. Let's do the fraction form. Do that here. Okay, so I'm going to rewrite the decimal as a fraction. I have -2/5 plus, I know that 2 and 3/10 is nothing but 2 and 3/10. So we're going to write it exactly how it is. All right. And then I can convert it to an improper. I can do the grouping method, or I can convert it to an improper fraction and then work it out also. So this is -2/5 plus 2 times 10 is 20 plus 3, which is 23/10. Okay, so I have this right now. And then I have to rewrite the fractions with a common denominator, because these are different denominators. I cannot add or subtract with unlike denominators, I've got to make them a common denominator. And so I am going to make this into 10. All right, because I know that the LCM is going to be 10, or the least common denominator is going to be 10. All right, so this is going to be times 2 gives me 10 times 2, right? So that becomes my negative 4/10, and plus I have 23/10, right? Now, since these are going to be opposite signs, all right, I'm going to add these fractions. Since they are opposite signs, I am going to have to subtract and give the sign of the bigger number. So 23 minus 4, and I'm going to get 19/10. All right, and 19/10 with the sign being positive, because 23/10 is greater. All right, and 19/10 is nothing but 1 and 9/10. So if I simplify it, I know that if I am dividing by 10, it is 1 and 9/10. Okay, or if I convert to a mixed number, 1 and 9/10, which is what? Same thing as that. This is also this. Okay, so this is correct and this is correct. So you end up with exactly the same answer, whether you are adding or subtracting with using both formats as decimals or using both formats as fractions. All right, but convert them to the same format in order to add or subtract. All right, so this was adding. Let's look at when adding 3 or more irrational numbers. Use the commutative property to group numbers by signs or forms. And grouping by numbers with the same forms can help simplify the expression. So this is when I have, 3 or more rational numbers. Okay, so let's do an example. And all right, so let's do a problem like this. Okay, so if I give you negative 266 plus negative 12 and 5/10, all right, plus 26 and 3/5. Okay, and then plus negative 3 and 1/2, plus 397 and 3/10. Okay, so if you're given something like this, please try to convert them to the same format. It makes it so simple. I'm going to write fractions as a decimal first. I'm going to show you that method, and then we will use the properties to group them together. So I have negative 266 plus negative 12 and 5/10. I am going to convert that into my decimal. So 3/5, that basically means 6/10, right? So 26 and 6/10. And this is what I did. I just took 3/5 and I made it over 10 times 2 times 2. And I got 6/10, which is 6/10 over here. All right. Plus negative 3 and 1/2 is what? 5/10, right? So here we go. And we have plus 397 and 3/10. So now I have put them all into the same format. I've written all the fractions as decimals. And now I am going to use the commutative property, in which I am moving numbers like this, the order to and fro, in order to group the like terms and or the like signs and together. Okay, this is what I mean. I have negative 266 plus I have negative 12 and 5/10. I'm going to bring that over here, my plus negative and negative 3 and 5/10. So as you can see, I am grouping the same signs together, but for this, I had to do the commutative property to bring this next to this, all right? Next to this. So now I do 26 and 6/10 plus 397 and 3/10. So I used the commutative property over here. I used the commutative property here, okay, in order to group the numbers like this. I've changed the order. Okay, so commutative property. All right. Next, I'm going to use the associative property of grouping. Okay, that means I am going to take these numbers. I'm going to group these together because they are like signs, so it will be easy for me to just add. So I'm going to group these together. And I am going to group the positive integers, the rational numbers together. All right. So now, since they are the same sign, all of these, I am going to add them. And I get negative 282 when I add these. And then the same sign on the other side, I have the positives. So that is going to give me, I'm going to add those numbers and I'm going to get 423 and 910. So as you can see, I have this grouping over here. This is the associative property that is being used. All right. And now all I do is I am going to add these numbers. And since they are opposite signs, I am going to have to subtract and give the sign of the bigger number. So when I subtract, because of the opposite signs, 423 and 9/10 minus 282, I'm going to get 141 and 9/10. Sign in front of the bigger number is positive. So therefore, my answer is going to be a positive rational number. Okay. So this is with me converting them to decimals. All right. Now, let's do a problem now where we are going to go into subtraction. All right. So when we are subtracting, what do you call it? Rational numbers. When subtracting rational numbers, the rules that apply to subtracting integers also apply to subtracting rational numbers. And in order to subtract two values, you need to convert them to exactly the same form, just like we did with addition. Okay. So let's do subtraction now. All right. So if I give you a problem, 2 and 2/5 minus 6 and 5500. All right. So if I give this to you, I am first going to show you writing the mixed number here. This straight. Okay. So write the mixed number or fraction as the decimal first. Okay, because that is the first thing I'm trying to do, is to convert it to the same format. So we'll start with using both in the decimal form. Okay, so if I look at 2 and 2/5, all right, this is nothing but 2 and 4/10, because I did what? Times 2 times 2. That gave me 2 and 4/10. Because as we know, decimals go in that 10th place value format, so it becomes easy. Minus 6 and 5500, and this means 2 and 4/10 minus 6 and 55/100. Now that we have exactly the same format, it is going to be so much easier to calculate these numbers. Um, and now we know that this, when I say minus, we have done already how to do is the same rule as addition subtraction of integers. So you are going to add the opposite. So opposite. So this is exactly what we're doing. All right. And when I do that, I get 4 and 1500. And then I look at the sign in front of the bigger number, which is negative. So this is going to be negative 4 and 1500 is my answer to this. All right. So this is when I converted them both to the decimal format. Okay. We can also rewrite using fractions or mixed numbers. So I'm going to do the same problem, but now I'm going to convert both of them to the fractional form. Okay, so I had 2 and 2/5, and what was this? 2 and 2/5 minus 6 and 5500. This is what I had, right? So 2 times 5 is 10, and 10 plus 2 is 12/5. All right, minus, this means 6 and 55 over 100, right? And this basically means what? 12 over 5 minus 655 over 100. All right, and now I can see that 100 is definitely going to be, because the denominators are different, I've got to convert them to the same denominator. So when I am adding or subtracting, so I'm going to make this 100 minus this 20. Okay, so 20 times 5. All right, so if I have 12 times 20, I am going to get, I know that 12 times 10 is 120. So 12 times 20 would be double that amount, which is 240. Okay. And then I'm going to look at, okay, these are opposite signs. So this means 240 over 100, add the opposite. All right, so I'm going to take 655, and from there I'm going to subtract 240. All right, because they're opposite signs, and I get 5, and 5 minus 4 is 1, and 6 minus 2 is going to be 4. So this gives me 415 over 100, and the sign in the front of the bigger one is the negative. So this is minus. And this is the same thing as what I have got, because this means what? 4 and 1500. So look, whether I do it this way, and this is minus sign, whether I do it this way or I do it this way, I still end up with exactly the same answer. So I just wanted to show you, change them to the same formats, change them both to decimals or change them both to your fractional form, and then you add or subtract, okay? So if I give you -3 and 2700 minus -6 and 7/10. So again, same rules as integers. Removing negativity gives me positivity. Or, so once again, removing negativity gives me positivity. We've done that before. Or you're basically doing in subtraction, what are we doing? We are adding the opposite, okay? So this is going to be negative 3 and 2700. Add the opposite of negative 6 and 7/10 is positive 6 and 7/10. All right, and now they are opposite signs, so I am going to subtract, and I get 3 and 4300, and then the sign in front of the bigger number is what? Positive, so this is going to be a positive number. All right, so that's going to be my final answer. All right, so let's say if I have x minus y, okay, if I have x minus y, you might have something, evaluate this. All right, and then x is negative 2 and 4/5, and y is going to be 1 and 4/10. Okay, so 1 and 4/10. So again, you can choose whichever method, whether you want to use decimals or you want to use fractions. You will still end up with exactly the same answer. I am choosing to use decimals because when I see the denominator as 5, I know it's very easy to convert to 10th. Okay, so it's saying x minus y. So x is negative 2 and 4/5. I'm just going to substitute the values at this point. I'm going to replace x with negative 2 and 4/5 and y with 1 and 4/10. Okay, and I know that I can do this. I can do this and I can do this, right? So I'm going to get negative 2 and 8/10, right? And 8/10 means what? This is actually nothing but here, negative 2 and 8/10. That's basically what I've done. All right, minus 1 and 4/10. So we are adding the opposite, negative 2 and 8/10 plus opposite of 1 and 4/10 is negative 1 and 4/10. So same signs, just add them. And when I simplify, I get negative 4 and 2/10. Okay. And then again, if I want to do the fraction format, I can, just like I had shown you earlier. But all of these lessons, please remember in this adding and subtracting, convert them to the same format. And when they are both decimals, when they are both fractions, it becomes easy to add or subtract. The rules for adding and subtracting rational numbers is literally the same as we had done with adding and subtracting integers. All right. Have a great day, y'all.